So in scalar multiplication, we have to multiply a matrix by a scalar. Here it is considered, the scalar is considered 3 and matrix is considered A. By this scalar, we just have to multiply each and every element of the matrix. Very simple way we have to multiply, we have to have the scalar multiplication. So 3 is just here outside the matrix A and A is here simply written, and now the resultant matrix to have, we have to multiply all the elements by this external constant is 3. So 3 into 3, 3 into 1, 3 into 1.5. That is, first row is multiplied. So first row we have got this 9, 3, 4.5. If the second row similarly multiply by 9, then we will be having this second row. And third row is multiplied by this constant same 3, then we will be having this row, third row 6, 0, 15. So this resultant matrix that we have, it is obtained by multiplying the matrix by the constant 3. So scalar multiplication, simply we have to multiply all the elements of the matrix by the scalar constant. Very simple multiplication. Negative of a matrix is, it's nothing, just when you multiply a matrix by -1. Here it is scalar multiplication. -1 into A means it is also a scalar multiplication. Scalar is here -1. Matrix is here A. So when negative of a matrix means minus A notationally, simply it is minus A, that is negative of the matrix A. And the negative of the matrix A means, how can we have negative of a matrix? So it is scalar multiplication. Scalar is -1. So all the elements of A, when are multiplied by -1, that is all the signs of the elements will be reversed. If some element inside A is positive, then it would be negative. If the element is negative, then it would be obviously positive, because elements are multiplied by -1. So it is simply negative of a matrix, is termed as negative of a matrix, and written simply minus of the matrix A. It is A minus A, if it is B minus B. Difference of a matrix, it is just simply subtraction between two matrices. So already we discussed in the last class. Here in the example, very simple example here is scalar multiplication. So A is given, B is given here. Then find twice A minus B. Find twice A minus B. You know, A is given here 2 by 3 matrix and B is given another 2 by 3 matrix. So that means orders of the matrices are same. So since orders are same, so addition and subtraction hold. That means allowed to perform addition or subtraction. We need to find the value of twice A minus B. So again it is difference of two matrices, the subtraction between two matrices, but B, it's no problem, B is ready. Again A is also given, but twice A is not given directly. So we need to have first twice A. So when we get twice A, then we subtract B from it. So that is the simple algebra. Here twice A minus B, so we can write in matrix form 2 into, here bracket is absent actually, it is misprinted. This is matrix form, again this is matrix form, and this is minus B. So 2 into a, twice a means 2 into a. So all the elements of a are multiplied by 2, it is scalar multiplication. So this is twice a matrix. This is twice a matrix. And b is what? B is this one. B is this one. So before b minus is there, before b minus sign is there, so we can multiply minus by minus 1 all the elements of b, then sign of the elements of b will be reversed. It is plus 3, it will be minus, it is minus 1, it will be plus. So it is actually minus b. It is minus b. So minus sign is considered with b, it is minus b. Again it is twice a, so in between this sign will be positive. Here it is twice a minus b. So since minus b is got ready here, so the sign here middle would be uh, positive. Now it is simply addition of two matrices. Just adding the corresponding elements, we can get the matrix. So this is the resultant matrix. That means twice a minus b represents this matrix. So obviously all are order of order 2 by 3. So resultant matrix is also obviously 2 by 3. Some properties are here. Addition, these properties are exactly same with the real numbers. So at the time of solving the problems, you do not have any problem. And the new property you'll be having related to scalar multiplication, it is little bit new. It is, so I am giving little bit ideas on the properties exclusively for scalar multiplication. Now say to handle with this operation scalar multiplication in matrices, some properties we should know here. Notationally, you know, A is this matrix, B is another this matrix, two matrices of order mn considered, no problem. And here look at the screen, and number one, k into a plus b within bracket. Here a b matrices and k is constant scalar. So here in a situation that sum of two matrices is here and again it is multiplied by a scalar. So for simplification, we can write in this way. That is k into a and plus k into b. That means we have to multiply both the matrices by the scalar. 2, property number 2, if you see k plus l, 2 constants, scalar constants, and then whole into a. A is matrix, but these two are constants, scalar constants. So matrix A is here. So similarly with the like the number 1, we can write at the time of simplification as we need. We can write like this: k into a and l into a. It is simple, like distributive property in numbers, real numbers. So we can write like this. And so k into a plus b is equal to k into a plus b. It is just detailed here. Proof is given here that 1 and 2, why and how we can write relation number 1 and relation number 2. Let's look at example for more clarification. You see here, A is one matrix here, B is another matrix. In A, 3 rows are here, 2 columns are there. So 3 by 2 matrix. B is another 3 by 2 matrix. So two matrices are here. And we need to find, as per the example statement, twice of A plus thrice of AX is equal to 5 of B. 5 of B. Okay. This relation is given. From this relation, simple equation, this matrix equation, because matrices are involved with this equation. So it's matrix, simple matrix equation. And here X is unknown matrix, B is here given, A is given, so X is unknown. So we need to find this matrix X. Here simply similar to the real numbers simplification, it is twice a plus thrice x is equal to 5b, it is given. So twice a plus thrice x minus twice a is equal to 5b minus twice a. That means twice a is subtracted from both sides. And finally, we are having thrice x alone, that is unknown matrix X contained term is alone in the left hand side, and this was our target, to keep X alone in the left hand side. So it is zero matrix. With zero matrix, any matrix when you add, so it remains the same, because the elements, all the elements are zero here, and whatever elements are here, just adding, this will exist only. So thus thrice X, that is X contained term, remains in the left hand side, is equal to right hand side, will be, we are having 5b minus a. X is unknown here, and we are going to find the matrix sorry, X. So X is equal to, we need to find here, so the constant, scalar constant with X, definitely we have to bring towards right hand side, and definitely it would be 1 by 3. Now within bracket it is 5b minus twice a, it remains same. So it is very simple algebraic simplification, as you all are familiar with the real numbers calculation. Now up to this step, simply for our convenience, the matrix A and B, whatever matrices given for A and B, these are not placed here for the convenience of this simplification. Now X is alone in the left hand side, so we can put the elements for matrix A and B as given in the statement, we can place here in the right hand side. And if we place here, then B is this one and A is 2 into A is this one. Now it is simplification, normal simplification. So 5 into this matrix, so it is scalar multiplication. So all the elements we have to multiply by this 5. So A matrix will be having here. Similarly, all the elements of this A matrix, it was have to be multiplied by 2. It is scalar multiplication. Again, we'll be having one matrix here and another matrix is here, and outside the bracket constant 1 by 3 remains as it is, and this step leads us to this one. So this is actually 5 of B matrix, resultant matrix, that is multiplying all the elements of B by 5, and this is the other matrix A, which all the elements of which matrix are multiplied by 2. So this. So now it is simply addition of two matrices. Addition of two matrices, that means corresponding elements we have to add just. And adding corresponding elements, we will be having from these two matrices a single matrix, and which has to be multiplied by finally 1 by 3, the constant lying outside. So here it is, you see 1 by 3, just corresponding elements are added here, and after simplification we have got this minus 6, minus 10, 12, 14, minus 31, minus 7. So this has to be again multiplied by 1 by 3. So finally this matrix we have to multiply all the elements by 1 by 3. So to multiply by 1 by 3, then we have this matrix finally. So this is the result of the unknown matrix X. So in this way, we can go for simplification related to matrices with basic operations, addition, subtraction, and scalar multiplication. And another example, if you observe here, x plus y, sum of two matrices given, 2 by 2 matrix, and difference of the difference of two matrices is given, another matrix, this one. And actually simple equation, matrix equation, two simple matrix equations, and using these equations like linear equations of two variable in algebra. So here also exactly similar process, left hand side plus left hand side, right hand side plus right hand side, and doing this normally we have twice x equal to this matrix. Therefore x is equal to half into this. This is scalar multiplication with half, and we got 4 4 0 4, this matrix. So x is equal to this matrix. So it is these are actually basic simplification related to matrix equation. And again that two relation, if you subtract left hand side minus left hand side, right hand side minus right hand side, that is uh, algebraic situation. These are one first the relations were added, and now relations are subtracted. Doing this we are having twice y. In the first relation we got twice x. Now it is we are having twice y. Now y is similarly this one. So 1 minus 2 0 5, we have got the matrix y here, and in the previously already we have it is x. So very basic matrix equation, with the help of the operations addition, subtraction, and scalar multiplication, we can deal with this simple equation, matrix equations. So just we need to have the understanding about the operations addition, subtraction, and scalar multiplication. So with these operations we can handle to some extent matrix equations. Uh, uh, this is another a little bit different example. Find the values of x and y from the following equation. This is another matrix equation. Here it is, all the matrices are in the equation 2 by 2 order, and it is mandatory because left hand side equal to right hand side. So left hand side is one representing one matrix, and right hand side represents another matrix. So order must be same. So all the matrices involved in a particular equation must be of the same order. So here you see in this matrix equation, two variables x and y are involved with the elements of a particular matrix. And here actually there are three matrices, two in the left and single matrix in the right. So in the first matrix, the two variables x and y are involved. So here our target is to have the values of x and y. So right hand side a single matrix and try to have left hand side first as a single one. So first one two it is scalar multiplication, and second was it is simple matrix we can add them. So by 2 if we multiply, consider scalar multiplication, we are having like this twice x 10 14 twice y minus 6, and plus this matrix 3 minus 4 1 2 it remains as it is, just adding, simple addition. So adding this will be having left hand side the next step, and right hand side obviously remains same. So in the left hand side adding the matrices will be having a single matrix in the right hand side, sorry left hand side. If we add the matrices in the left hand side, we are having this matrix, and right hand side it remains same. Now left hand side one matrix and right hand side another matrix. So left hand side we have converted into a single one. So now left hand side a single matrix, right hand side is a single matrix. So now two matrices are equal. So by the concept of equality of two matrices, we can consider the corresponding elements are equal, as we discussed in the last class. So now these two matrices are equal. So directly we can consider their corresponding elements are equal. So we can equate now corresponding elements. So by doing this, we have twice x plus 3 is equal to 7. So twice x plus 3, the first A11 position element. So in the right hand side, A11 position, it is 7. So these two elements are corresponding, so equal. Similarly twice y minus, from this equation, we can write twice x equal to simply this one, x equal to 2 we have. So from the first relation, we have got the value of x. And in the last, that is 2 by 2 element. 2 by 2 element is twice y minus 4. Twice y minus 4, its corresponding element is 14. Twice y minus 4, its corresponding element is 14. So corresponding elements are equal. So twice y minus 4 is equal to 14, we can write. So from this relation, we got here y is equal to 9. So x is equal to 2 finally we have got, and y is equal to 9. So this is another example that its matrix forms equations given here, and some variables are involved with the elements, and just using the concept of equality of matrices with operations. So little bit different example it is. So thus we can be familiar, we are now familiar with basic operations um, of matrices, that is addition, subtraction, and scalar multiplication. And I do hope you have understood with these basic operations, and how to handle these operations in simplification of matrix equations. Another um, multiplication is there in matrices, that is matrix multiplication. That means in this multiplication we have to multiply one matrix by another matrix. In scalar multiplication, one is matrix and another is non-matrix, that is scalar. So it is scalar multiplication. That means all the elements of a matrix, if are multiplied by a constant, scalar constant, whatever matrix we have, that is the result of the scalar matrix multiplication, scalar multiplication. And in the second type multiplication, one matrix, if we multiply by another matrix, so some condition are there. After fulfillment of that particular condition, we can go for matrix multiplication. So that will be discussed in the uh, next class. So I do hope you have understood clearly.